Welcome to the project demonstration of three-phase induction motor protection from phase and temperature fault. So this operation was achieved by the PIC microcontroller. So we are using PIC 16F72 microcontroller. So this will taking care of inputs. So in our project the inputs are three-phase checking for this using this three regulator power supply boards, and that will be isolated with the help of the switches. So here we are converting the single phase to three phase, and from there two switches will be placed, and the microcontroller will check the status of availability of the particular phase. Whenever the three phase are available, then only this load. So we are representing the 6 bulbs as a three phase induction motor, each phase for the 2 bulbs. So whenever the three phase available, then only these 3 relays will get switched on. So we are providing the 3 phases for the 3 phase of the motor. And one more checking is there, if is there any high temperature detected from the motor coils, means if a heavy load was there and then the motor body temperature will be increases, so that will be read by this temperature sensor, and whenever it crosses a threshold value, so we set the threshold value of around 50 degrees centigrade, and when it crosses that, then automatically the system will protect the motor from damaging by isolating the power supply to the motor through this same electromagnetic relays. And also the availability of the phases will be displayed through these LED indications. So coming to the interfacing connections, the checking input modules, these are regulator power supply boards, are connected at A0, A1, A2, A3 pins directly. A0, A1, A2 and A3 for this temperature sensor, and C6, C7 and C5 for the electromagnetic relays, and these LEDs interface at the C0, C1, C2 pins. So let us see the demonstration. So as this regulator power supply board consists of 4 stages. One is the transformation to step down the 230 volts AC to 12 volts AC, and next rectification to convert the AC to pulsating DC, and filtration to remove the pulses to make that as a smooth DC voltage, and regulation to make it as 5 volt, as the operating voltage for our microcontroller is 5 volt, mean it can measure the voltage up to 5 volt only. For that purpose only we are using this transformation, rectification, filtration and regulation. So let us see demonstration. This is the power supply for the main microcontroller motherboard, and then on the power supply to this single phase inputs. So as of now 3 phases are available. So we can see the LED indication as well as the bulb indication. So whenever any single phase fault occurred, so while doing execution we should not touch over this regular power supply boards, as it passes through the 230 volts AC off. Right. So everything was normal, but if high temperature detected from the sensor, we can see the LED indication on this board, as well as the bulbs will be isolated from the input voltage. So this LED will show the status of the system is execution. It's keep on checking the input from this phase checker as well as from the temperature sensor. So green phase, red phase and white phase. Right.